Combinations are pretty much the same as permutations or variations, but in combinations we don't care about the order. In permutations we cared about the order of elements. So to make things absolutely clear, permutation A and B is different than permutation B and A, but combination A and B is the same as combination of B and A. So let me show you an example. Imagine that I have set A that is containing numbers 1, 2, and 3, and I want all subsets that have 2 elements. This is pretty simple. It is actually 1 and 2, then 2 and 3, and then 1 and 3. But now I want to demonstrate the difference between combinations and permutation. In permutation, it would be A and B, A and C, then B and A, B and C, and then C and A, and C and B. And since the formula for combinations is not so easy to come up with, I will show you the formula right now. So that is it. Now, I will at least tell you what that means. So, since we are picking r elements from n, we can compute this n factorial divided by n minus r factorial. Why? Well, that is basically k permutation over n, right? It is the same formula, but this time we also need to get rid of all the cases where the only difference is in order. And we will do that by multiplying the down part of fraction with r factorial. And actually, let me show you that it works on this example. So, the number of all subsets that have 2 elements is 3, right? Let's see what this formula gives us. So, in our case, n is equal to 3 because we have 3 elements in set A, and r will be 2 because we are picking 2 numbers. Now we have all we need to compute this formula. On top will be factorial of 3, and we will divide that by factorial of n minus r, and that is 1, and then multiply it by factorial of r, so factorial of 2. Now, factorial of 3 is 6, because 3 times 2 times 1 is 6. Factorial of 1 is 1, and factorial of 2 is 2. So, we get 6 divided by 2, and that is 3. You might also see this notation, n choose k. So, for example, in our case, it would be 3 choose 2, and it is 3. Let's look at another example. Imagine that you have a group of 10 boys and 5 girls, and you want to choose 2 girls and 1 boy. How many options do you have when you don't care about the order? You can once again pause the video and try to do this on your own. So, let's split it into 2 tasks. First one is pick 2 girls, and second is pick a boy. So, we need to pick 2 girls from 5. So, in first round, we are picking from 5 girls. Then, when we are picking second girl, we have 4 options. So, 5 times 4 gives us 20. But now, we need to get rid of all the permutations that are different only in order. And we will do that by dividing that 20 by r factorial. So that is 2 factorial, and that is 2. So the result will be 10. You have 10 options how to pick 2 girls from 5 when you don't care about the order. Now, the second subproblem is to pick 1 boy from 10, and obviously you have 10 options, right? So now, since these were subproblems, we multiply the results and get the final result, and that is 100. I hope this makes sense. So let's move on to combinations with repetition. So we have been given n objects, and we want to select our objects with replacements. So imagine that n is 5. So we have item 1, item 2, all the way up to 5. And then r is 3. So we are picking 3 elements. But this time, when we are picking element, we will put it back into the set. So if I pick 3 as a first element, I will cross it right here, and then I add it to the end. Then I can pick, for example, 1, so I will cross it in here and add it to the end. And then I can pick 3 again, so I will cross it in here, and then I will add 3 again. And I'm done. I have my 3 elements. So we are actually doing 7 choose 3. And you already know how to compute this, so it will be 35. So let me show you another example. Imagine that we have this equation, x1 plus x2 plus x3 plus x4 is equal to 16, where all the x's are positive integer values. How many solutions to this equation exist? So what we are actually solving? Imagine that we have 16 balls and we are trying to get them into 4 boxes. That is actually what we are doing. Let's say that 2 goes into first one, 6 goes into second one, 8 goes into third one, and none goes into last one. And now imagine that instead of boxes, there are x variables. So first box is x1, second is x2, and so on. And if you compute that, you will see that it is actually 16. So what we are actually doing? We are dividing these 16 balls into 4 boxes. But you can also think of it as separating these balls, right? So the previous example can look like this. So this part represents first box, this part represents second box, this part represents third box, and this part represents fourth box. But now we need to find all the possible positions for our 3 separators, right? So what we are actually doing? We are picking 3 positions where to put our separators, and all these separators can, for example, be in front of all these balls. That would mean x1 is 0, x2 is 0, x3 is 0, and x4 is 16. So we are actually kind of picking 3 elements from 16 plus 3, right? And we don't care about the order. All the elements can be the same. So the result of this would be 18 choose 3. And that should be 816. So you might notice that we use this formula, n plus r minus 1 choose r. So if I get back to first example, we had 5 items and we were choosing 3. So 5 plus 3 minus 1 will be 7 and r is 3. And that is exactly what we got. So yeah, this thing is maybe a bit complicated. It might take some time for you to get used to it. So feel free to watch this video again. There is no shame in that, and I will see you next time.